Hello everyone, let's solve this LeetCode problem today. This problem is the last problem in the biweekly contest, and it's actually a hard problem, and the acceptance rate is pretty low. It's only a little bit above 10%. Okay, so let's take a look at this problem. Yes, problem is actually pretty hard to understand, so let's take a look at the example. So n is 4 means there are 4 nodes in this graph, 1, 2, 3, and 4. And there are some edges. It's an undirected graph, and the edge can be repeated. For example, there are 2 edges between node 1 and node 2. And for this graph, it means like since we have 4 nodes, so there are 6 pairs, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. And for each pair, we can get the number of edges like these 2 nodes on. For example, for node 1 and node 2, they have these 5 edges. For node 3 and node 4, only the middle 3 edges have has node 3 and node 4, so the count is 3. Okay, so the question is, given a query, for example, if query is 2, it asks us to return like how many pairs that has the edge that is greater than this query. For example, when query is 2, we know all the 6 numbers are greater than 2. So the answer is 6. Once query is 5, we know the previous 5 rows have numbers that is greater than 3. So we return 5. Okay, that's the problem. How do we solve it? First of all, we need to for loops queries, and for each query, we need to get one answer. And for specific query, we know the naive solution is we can double for loop nodes, but the number of nodes can be 2 multiplied 10 to the 4. So O square will become like 4 multiplied 10 to the 8, which will be TLE. So it's a slow solution. Okay, next I will talk about solutions that can pass the tests. So this is an example, and there are 2 edges between 1 and 2. And let's say one query 6 and 3. First of all, we have 3 data structures. The first data structure we use is graph. So it's a vector of unordered map. For example, for node 1, 2 is the neighbor of node 1 and 2 occur twice. And 3 is also a neighbor of node 1. 3 occurs once. Okay, for sizes, it's actually more like degrees. So for node 1, it has 3 edges, so the degree is 3. For node 2, degree is 4. And for node 4, degree is 2. Okay, then comes the perfect sum. Actually, it's not a perfect sum, more like a suffix sum, or I can explain it. It means like if it's 0 means there are 4 nodes whose degree is greater than or equal to 0. For 1, we know like there are 4 nodes, like the group degrees are greater or equal than 1. For 2, also 4. Like for 3, we know there are only 3. And for 4, there are only 1. So this array is very useful. Let's say one query is 3. If for a node, like for this node 1, we know the degree of node 1 is 3. So query minus the degree of node 1 is 0, which means we need to find other nodes whose degree is greater than 0 that can pair with this node 1 and make the number of edges is greater than this query, right? So one query is 3. Let's say this total is the result for 3. And note here, I will for loop each node and pair other nodes with the current node and add the answer to this total. Note I need to divide by 2 here. Since when I is 3, like I count 2, but when I is 2, I also count 1. So I count them twice. I need to divide by 2 at last. Okay, and this is our query, and our target is query minus the degree of I. Since we want to pair the current node like with another node and makes their like the total number of edges or total number of degrees is greater than query. Okay, so we can use this array to get that number. For example, one query is 3 and I is 1. We know the degree of I is, we know query is 3 and size is I is 3. So target is 0. So we need to find the number of nodes whose degree is greater than 0, which means I need to find the number of nodes whose degree is greater or equal than 1. So this number is what we want here. So I just plus prefix and target plus 1 here. But there are two wrong stuff, two bugs here. First of all, we know when I is 3, there are at most 3 other nodes that can pair with node 1. How can we get 4 here? Yeah, it's because we count 1 itself. So we need to exclude the current node. If the degree of current node is greater than target, we should minus current first. Like minus it by 1, since it will be incremented in this line. Okay, the second bug here is that for the pairs that neighbors, for example, 1, 2, they have 2 shared edges. So the total edges is degree of 1 plus degree of 2, then minus the shared edges, which is 2. So we cannot just simply use this line. So we need to separate the calculation of neighbors and non-neighbors node. Here, we will iterate every neighbor of node 1. And we do think if the degree of node, if the degree of neighbor is greater than target, we will decrease the current variable, since the effect will be added back in this line. Okay, next we just calculate the neighbor. So the total edges of my current node and this neighbor node is the degree of I plus degree of neighbor minus the common edges. As long as the number is greater than query, we get one more data, like one more pair here. So here's the solution. The tricky part is the count. We need to minus the count here first, since the effect of neighbor and the count node will be added back in this line. Since this perfect sum array contains like all the nodes. Okay, that's basically everything. Thanks.